Now that we have an equation for our fugacity, we now need to go about and find a pressure that in which, or the pressure in which the fugacity of our vapor phase is going to be equal to our fugacity of the liquid phase, right? We want to satisfy our equilibrium criteria. And so in order to calculate this pressure, we need to do this iteratively, where F liquid is equal to F vap. And so, in order to do this calculation, you need to follow these steps, or this algorithm. Okay. All right, and so for a given temperature value, what you want to do is you want to first calculate your pressures and then plot them versus the molar volume. Okay? And then based on this plot, you can look at the region of the plot in which the pressure corresponds to multiple volume values, and that would indicate that this is a region where it's possible for the liquid phase to be in equilibrium with the vapor phase. Okay? And so based on this plot, that will allow you to get an idea of what a good guess for the Psat would be. And once again, that's going to be in the region of the plot where P corresponds to multiple volume values. Okay. Once you pick a pressure guess, then you actually want to go about and calculate the volume roots. And then once again, same as what you've seen before, that low root is going to be equal to the molar volume of the liquid phase, and then the high root is equal to the molar volume of the vapor phase, right? And then that middle root, that's the one that's unstable volume and does not correspond to a physical value. Okay. Once you identify or calculate the molar volume of the liquid and the vapor phases, you could then go and calculate the compressibility factors for both the liquid and the vapor phase. And then once you have those compressibility factors, you can then calculate your fugacities. And then essentially what you want to do is you want to repeat steps 2 through 5 until your vapor fugacity minus your liquid fugacity is about equal to 0. Okay? Alright, so that's the basic algorithm for identifying, the vapor pressure. And what I want to do now is, showing an example of MATLAB code that I wrote in order to do this calculation. And so to do this calculation, I actually wrote 2 separate scripts, where the first script is just used for calculating fugacity, and then the second script takes that first script and then minimizes it in order to find the vapor pressure that minimizes the difference between the vapor and liquid fugacities. Okay? Alright, so in this first code is just used to calculate the fugacities of the liquid and vapor phases. Okay? And so I just call this code fugacity version 1. And so in the first section of the code, all it does is just plots pressure versus volume. Okay? And so what I do is I just tell it a range of volumes that I want it to look at, and then I define the van der Waals equation, and then I calculate those pressures. Okay? And so here's a zoomed in version of that plot. and specifically I'm zoomed in on the region in which you get pressures that correspond to multiple volume values. Okay. Now, when we look at this region, the reason we're looking at it is because we want to get a good guess for a pressure that is going to correspond to the vapor pressure. And so when we look here, we see that the pressure values, have a very steep slope at low molar volume, and then even go negative, and then come back up, hit a maximum, and then tail off. All right. And so when we're picking a guess for pressure, first of all, you don't want to pick anything that's like a negative pressure. That's not a realistically physical value. And so don't pick anything less than 0. And when we're looking here, basically, if you just kind of draw a line from here across, you could see that this line will cut across 3 different volume values. Okay? And so for our initial guess, I'm just going to say, all right, if I pick halfway between 0 and 200, since the maximum pressure is around 200, I think that's going to be somewhere around the vapor pressure. Okay? And so for our initial guess, I'm just going to pick a value of like 105 or so. And so if I pick around 105, for here, that's going to correspond to a molar volume value of, about 2. I'm going to ignore that middle root. And then for the larger root, that's going to correspond to a molar volume value of about 40. Okay? And so for my guesses for volume, for the lower root, I'm going to guess about 2. And for the higher root, I'm going to guess about 40. Okay? All right, and so in this code, I define an objective function that takes the van der Waals function as a function of volume, and then subtracts off whatever pressure you initially guess. Okay, so I'm having that objective function, and in order to figure out the volume, I want to minimize that objective function. Once I have the volume, then I would calculate z and then calculate f. Okay, and so in this next section, that's exactly what I do. So I take to calculate the molar volume of the liquid, I use the f0 function to minimize the objective 1 function, where my initial guess is about 2. And then I calculate z and fugacity. And then for the vapor molar volume, I do the same thing, except all I do is just change my my volume guess to be larger. Okay. All right. And then after I calculate, the compressibility factors and the 2 different fugacities, I then have this function just calculate the difference between, and I guess here I did fugacity liquid minus fugacity volume. Okay, and so that's going to be the main output of the function. Okay, so calculating the difference between those 2 fugacities. All right, so that's the first layer of the code. The second layer of the code is a function I wrote where specifically I want it to find the pressure that minimizes the difference between the liquid and the vapor fugacities. Okay? All right, and so in this second layer of the code, all I do is just input a temperature, and then I once again call up that fugacity function that I wrote here. I call that up in the second code. Here's where I actually put in my guesses for the molar volume of the liquid and the molar volume of the vapor. And then for, in this case, I'm only looking at one temperature, so the for loop is actually not needed. But essentially, to calculate the vapor pressure, I just also run F0 to minimize this fugacity equation, where my initial guess for pressure is about 100. Okay? So that's the idea there. All right? And so when I run this script, I left an uncommented psat here at the end. And so when I run the script, essentially we could see how, you could look at how the molar volume of the liquid and the molar volume of the vapor are changing as it's iterating on the pressure value. Okay? And so you could see that the molar volume of the liquid, the molar volume of the vapor are actually, not changing too much as it goes through these different iterations. But eventually, when it gets to these values and it gets to a pressure of 104.8, that's when the objective function 2 value, the difference between the two fugacities, is minimized. Okay? All right, and so by doing, writing these sort of MATLAB codes, I'm able to identify iteratively, what the vapor pressure is. All right, and so in this MATLAB code, or codes, we get that P sat is just going to be equal to 104.8 psi. Okay, and so that's going to be example of the basic approach for using the fugacity method for determining vapor pressure.